Hi, I'm Giovanni Hernandez, and we're going to be looking at Wantzel's theorem. So, what is this theorem for? It was used to prove that the trisecting of an angle and doubling the cube was impossible. And why was it impossible? How could he just not trisect an angle that's arbitrary, or find the side length of a cube that's been doubled? So, like, if we're given the volume of a cube is 1, we know the side length is 1, but if we double that, we don't know the side length of that cube. Seems pretty confusing. But why was this impossible? It's because of restrictions set by Plato, who was a Greek philosopher that was challenging the Greek mathematicians into solving this problem, but through only using a compass and a straight edge. This made it infinitely more impossible. So let's see who was Wantzel and who basically inspired his work and led to his theorem. Wantzel was a French mathematician born in 1814, and his theorem was brought about by many mathematicians, beginning with Euclid, who was basically like the founding father of geometry, and his postulates were the foundation for solving this problem. But since Plato challenged Euclid to solve this problem using only a straight edge and a compass, using arbitrary numbers, it was hard for him. So then Descartes tried to challenge the problem in the 16th century, and he basically found that using cubic roots did not help, but it helped him find a little foot further in translating the problem from geometry to algebra, where he was basically trying to find a way to find a polynomial or a cubic root of a polynomial that he could sort of construct. He reached a dead end because he found a cubic root, but he found one that he could not construct. So then Lagrange and van der Moon found solutions to general polynomials, which would then be used to find regular polygons. And this basically used Descartes' work in a way where they would find the cubic roots of these polynomials, regular polygons, and find a way to construct them. Well, Gauss used Lagrange and van der Moon's work to find that that's pretty much impossible to construct a heptadegon, and that's through the ways of like finding the roots of such polynomials that are to higher degrees. So how is this all connected to Wantzel? Well, all this work led to his theorem, which is if r is a constructible number, it must be the root of an irreducible polynomial degree 2 to the nth power, which is all found through the work of Gauss, van der Moon, Descartes, Lagrange, and Euclid. And this proved the impossibility of the classical problem of doubling the cube and trisecting the angle using only a compass and a straight edge, because it showed that if you could not find the root, or if you could not find a constructible number that is equal to the irreducible polynomial of the degree of 2 to the nth power, it's because you couldn't find the root of an irreducible polynomial of the degree 2 to the nth power. This is all pretty confusing. I feel like you guys may not grasp it, but how does this affect us? How could we kind of use this in our lives? Well, we can look at the foundations of this theorem, and we can look at the cube, looking at the volume of a cube, where we can find that the volume of a cube comes from sort of Euclid's work in geometry. And we can also look at finding the quadratic formula to find roots of a polynomial, quadratic function at least. And we can also look at polynomials and how they use these sort of polynomials to find their roots and get an answer for this impossible equation. And although it is impossible to try, you can try it yourself and see if you can find the answers. But as you can see, it's been proven impossible. So if you want to find it using a computer program, or if you want to be able to trisect an angles with using only compass and a straight edge, you can thank Wantzel for proving that it is impossible to do.